Now that we talk about electrons, we can talk about electric current. Electric current is simply the rate of flow of electric charge. Let's look at the example here to the right. Let's say you have an electrical wire, so like a piece of copper, for example. So we are looking at a section of the wire. The wire actually continues here and there, so it's just a little section of it. And let's say you have 3 electrons on the left side. And you are an observer, you are somewhere in the middle of the wire, and you just monitor a certain section of this wire. You just look at a particular section. Now, I could ask you to do a certain experiment, which is in a certain amount of time, delta t. You can choose the amount of time. It could be 1 second, 1 hour, 1 year. It could be 1 microsecond. It could be as long or as short as you want. You will just be sitting there and count the number of electrons that pass from left to right. At the end of the experiment, you will have a certain number of electrons here, and E. And if you multiply the electron by E, which is the charge of 1 electron, you basically know what is the total amount of charge that passed. If you divide the total amount of charge that passed, which I'm writing as Q here, by delta T, what you get is the electric current. Electric current is the amount of charge that passed during a certain time along a wire. The unit of measurement of the electric current, the natural unit of measurement, will be Coulomb divided by second, because we have charge divided by time. But because the current is such an important thing, it has its own unit of measurement that is called ampere, and it's indicated with A. So you can see here I substitute Coulomb divided by second with A. There is a very important thing to remember, which is the convention of the direction of the current. The general convention is to have the direction of the current to be the same as the direction of movement of positive charges. What does it mean? Given that usually in electric circuits and wire, what moves are really electrons, and electrons have a negative charge, the direction of the current is the opposite of the movement of the electrons. So in this case, that will not be the right direction. Let me cancel it. But the direction of the current that you measure will be the opposite. It will be in this direction, so from right to left.